Hi everyone, this is Charan here. Welcome to my channel. Today in this video, we are going to talk about 5 common data science terms that are usually asked in data science interviews. When people ask you about these terms in an interview, they want to know whether you have a good understanding about these concepts or not. So let's directly get started with this video. There are 5 topics that we are going to cover today. The topics are like what is dependent and independent variable, what is an outlier, and how to identify outliers, what are all the various techniques to identify outliers, what is an ordinal attribute, what is one-hot encoding and when it is used, and what kind of problems are solved using one-hot encoding, and finally what is an imbalanced data set, right? What is the issues with an imbalanced data set, how we should approach it. So these terms are commonly asked in interviews. So let's get to the first topic. What is the dependent as well as the independent variable? So in any predictive data science problem, what we would have is we would have a dependent variable and we would have a number of independent variable. Usually there will be one dependent variable and there will be a number of independent variable. So when I say a dependent variable, as the name suggests, what it means is it means the value of this variable is dependent on something else. So the dependent variable is the variable that we are going to predict. The value of this variable is dependent on the various other inputs that we are going to pass on to the algorithm, to the model. The independent variable, on the other hand, is the various attributes that we are going to use in order to predict the dependent variable. So if I take a simple example, let's say I want to predict the sales of an particular retail store. So this is the dependent variable predicting the sales for a particular retail store on a particular given day. The independent variables could be such as like the number of customers who are walking into the store on a given day. What is the amount of rainfall on a particular day? How is the weather on a particular day? Is it sunny or is it cloudy or is it like a good temperature? So whatever it could be, that there are various independent variables. These variables are called independent variables because they are independent of each other. For example, the number of customers coming into a particular store as well as the amount of rainfall on a particular day are independent of each other. There could be some relation, maybe if one increases the other increases as well, or if one increases the other decreases to a certain degree, but they are not highly related to each other. In general, in a predictive problem, what we want to ensure is we want to ensure the independent variables are all independent. If there are any highly correlated attributes, we try to eliminate them. The dependent variable is the one that we are going to predict it. So this is the difference between the dependent as well as the independent variable. Usually students who are trying to learn data science, who are just getting started with data science, try to get confused with these terms. So if you understand like this, it becomes very clear. So the second topic for today is outliers. Right? Outliers is a very common issue. In any data set that you take, there will be a number of outliers. For example, let's take like a price of a particular property. So even though the majority of the property would lie in a particular range, there will be a small amount of property which will be like extremely expensive and some which are like extremely less expensive as well. So there will be outliers definitely either side. In any problem, right, any attribute, if you take like for example age of the customers, your normal customers age range could be between a particular value, but there will be definitely some outliers. So there are some techniques in order to identify the outliers. First one is that if you use an box plot, you would be able to clearly identify like whether there are outliers or not. What you can do is in order to clearly, like in order to exclude those outliers, you can use something called as an z-score. So z-score is a technique where what we do is we plot the normal distribution and then we try to identify how many elements are like a 1 sigma away from, like let's say like the center of the distribution. How many values are within the 2 sigma range, how many values are within the 3 sigma range. Usually in order to eliminate the outliers, what we do is we filter any values that fall outside, let's say 2.5 sigma or 3 sigma or 3.5 sigma. So usually we, depending upon the problem, depending upon the attribute, we come up with a particular threshold, and whatever values that fall outside that particular range, either we eliminate it, or if we want those attributes to be included, in some cases it makes total sense to include some attributes. So the price of the property is an exact like an example. Like even though there are some properties which are like extremely expensive, if we eliminate those properties from our data set, then it becomes very hard to predict the value for those properties which are extremely expensive. So it made sense to include all of them in our data set. So what we need to do is, in those cases, we need to come up with some kind of a treatment plan in order to handle the outliers, like either log transformation or any other transformation, by using which we would be able to accommodate all the values, and then it can make sure that they are either normally distributed or like within a particular range. So that's about the outliers. So as I explained, so the outliers can be identified using like a Z-store, and the other technique is isolation tree. So isolation tree is an excellent example, especially like when you have attributes which are in different scales. Like for example, you have age and you have salary, which is of different scales. So in those cases, what you can do is you can use isolation tree in order to identify all those attributes which are like all those values or all those records which have outliers. So that's about outliers. So the third topic is the ordinal attribute. The ordinal attributes are all the attributes that have some kind of a sequence within them. For example, the ticket class. So if you take a flight, the ticket class could be like a first, second, and maybe third. So this particular attribute, the three different values that we have, it has a sequence within it. For example, the first class is the most expensive one. The second class is like maybe slightly less expensive. The third class is the least expensive. So there is a sequence within them. So when we have an ordinal categorical attribute, what we usually do is we use integer encoding. For example, what we will do is if it is first class, we give a value of 1. Second class, the value as 2. Third class, the value as 3. So whatever the sequence that is captured in the categorical ordinal attribute, we maintain the same sequence when we use the integer encoding. By that way, what happens is the algorithm would be able to know when the class like reduces, like for a third class, like how the pattern is, what happens to the actual end result. When we have like someone who is bought the first class ticket, like what is the behavior? So when we look for like maybe when we work on a predictive problem or when we work on an data analysis, by using integer encoding and capturing the internal sequence that is present in the data, we would be able to identify the various patterns for that particular attribute. So that's about the ordinal attribute. Whenever we have an ordinal attribute, what you need to do is you need to ensure that whatever be the sequence that are within them, we need to maintain the same sequence when we use the integer encoding. The fourth topic for today is one-hot encoding. So one-hot encoding is a popular technique that we use when we have a non-ordinal categorical attribute. So for example, gender is an excellent example. Country, city, all these are excellent examples for non-ordinal categorical attribute. What it means is they do not have any sequence within them. Like a male, female, or people of any other gender are all same. There is no sequence between them. Like people coming from different countries, like no matter from which country you come from, like all of those people are are same with each other. Like there is no internal pattern as compared to a class of an flight ticket. So people coming from different cities, all these are like a non-ordinal categorical attribute. When we have these non-ordinal categorical attribute, if we use integer encoding, for example, let's say we give in case of gender, we give 1 for male, 2 for female, and so on, then what happens is when we use this integer encoding to an algorithm, the algorithm try to come up with some kind of a false assumption. When the value is higher, it tries to see if there is any pattern to the end result. If the value for the gender increases, what happens to the end result? If it decreases, what happens to the end result? So it tries to come up with a pattern when actually there is no pattern that exists within that particular attribute. So we are trying to pass on a false information to an algorithm, and hence it becomes very difficult to make an accurate prediction. So in those cases, what we do is we use something called as an one-hot encoding. So for each of these attribute, for example, in case of gender, we have male, female, and whatever it is, we use integer encoding, and then we use binary coding for those attributes. For example, like whatever be the attributes, we convert them into columns, and then we use 0 and 1 in order to uniquely identify each of those values. By using this particular method, what happens is the algorithm is able to identify like uniquely that particular value. It doesn't try to come up with any pattern when there is no actual pattern that exists for that particular attribute. So in case of non-ordinal categorical attribute, what you need to do is you need to use one-hot encoding that will help you a lot in order to predict the problem more accurately. The accuracy of your solution will generally increase when you use one-hot encoding for all the categorical attributes which are non-ordinal. The final term for today is imbalanced data set. So this is again a common problem. If you have an imbalanced data set, you need to ensure that the evaluation metrics that you are using, the approach that you use in order to build the predictive model is not same as when you would approach a normal problem. So what is an imbalanced data set? Imbalanced data set is something where, for example, let's say we want to predict whether a transaction is fraudulent transaction or not. So the distribution between these two are very much imbalanced. For example, like 99.9% of all transactions are all genuine transaction. It is only the 0.1% which is the fraudulent transaction. So the distribution between them is like too huge. If I build a predictive model that says like 100% of all data are genuine transaction, then the accuracy of my particular model is 99.9%. Because all like out of all the transaction, 99.9 transactions are all genuine. So I need not make any effort. I just want to ensure that all transactions are genuine. So in these problems, what we need to do is we can't use the standard evaluation metrics. We can't use the data as it is in order to build the predictive model. If we pass on this particular data as it is, then it becomes very difficult. We won't be able to model for those fraudulent transactions. So what we do is we try to identify, we try to increase the number of samples that has the fraudulent transaction. We try to duplicate it. We try to come up with the different versions of it, and we use different techniques in order to ensure that the distribution between like genuine and fraudulent transaction are more similar, and hence like our model would be able to predict or identify all the fraudulent transaction. So when you are asked about imbalanced data set, it's very important for you to explain like what the imbalanced data set is with an example. The credit card fraudulent transaction is an excellent example, and then you can come up with the approaches to handle the imbalanced data set. What are all the various problems that you have with the imbalanced data set? For example, the evaluation metrics. So that's about the imbalanced data set. So we have covered 5 terms today. I hope you would have understood about these 5 terms in detail in this particular video. If you enjoy what I am doing here, please give a thumbs up and subscribe to my channel. And that's it for today. I will see you in another video. Bye until then.